That's looking good. I want you to also notice this. What's understood to be in front of the A? 1A right here, right? Hey, what's 3 divided by 3?
1.
What's 6 divided by 3? So, just like multiplication has a distributive property, so does division. So when I divide by 3 like this,
It's easy.
that's 3A divided by 3
That's
plus
8.
6 divided by 3. And then you just simplify.
That's 8.
That's a 1, so A plus 2
Oh.
is equal to 5. Is that the same? We
Yeah.
get that?
Mm-hmm.
Right faster. Okay, like how to get this one? Okay. Which of these 3 equations do you think would be best to use to show this is equivalent? The first 2? But you just need one of them. The second one, right? That's the closest. Any hints looking at these 2 about what you might be able to do? Because notice I don't have anything added or subtracted here, nothing here. Divide by, is that what you said? What are you thinking to divide by? Okay, so if I divide by 3, I get 3 divided by 3 is 1, which is A, equals, does that look exactly the same? Say it one more time, Kelsey. What about if we divided by 9? What's 9 divided by 9? 1. Okay. 3 divided by 9? That's going to end up being a 1/3. Ireland doesn't like that. What's 3 divided by 3, Ireland? 1. What's, so I'm dividing by 3. What's 9 divided by 3? So that's a 1 divided by 3. But also, really quickly, everybody pick up your calculator. Type in 3 divided by 9.
9.
Type in 3 divided by 9.
9 divided by 3 and 3.
3
Oh.
divided by 9.
I got 1/3.
That calculator will kick out a simplified fraction for you. Don't make it harder than that.
Okay, so the homework.
So let's look at a couple of homework questions before we move on to the next part of the lesson. We're not going to do that. Yeah. So lesson 6 homework questions. Okay. Now, as anyone who has had me knows, especially those who had me last year, yes ma'am. Did you go before class starts? Didn't I let you go before the class starts? Huh? I know, I told you to do your calculator and then you could go. Did you not go then? Okay. The whole point was that if you did your calculator stuff before the bell rang or as the bell was ringing, the bathroom would be clear out. Go ahead and go use the restroom now, but be aware that that's what I'm saying is you can go right after the bell rings if you've already got your work done. Alright? So I appreciate you having done your work earlier, that's why I'm letting you go. Alright, so number 1, which equation is equivalent to 6x plus 9 is equal to 12? Okay? So, now, I heard Dee say B, as in boy. How did you get that it's B? You looked it up online.
I did a calculator
Yeah.
that,
Exactly.
and then you put all the information.
So you solved each of these equations?
Both sides.
You what?
Okay, so first what I did, I divided both sides by 3.
So you divided this side by 3 and this side by 3? Okay. Hey, what property does division have that we just talked about? Not commutative. Say it again. Distributive, right? So I can distribute that division by 3. So what is 6 divided by 3? 2, so I have 2, 2
Two
X,
X.
2X
X
plus 3.
plus 3. Hey, are those exactly the same? So are those equivalent?
Yeah.
Okay,
Wait, so like,
that's all you had to do?
so you just want to get one answer?
Well, it says which equation. It doesn't say all the equations, it just says which equation.
Okay, that's,
Oh, so I did it right.
That's why I did
Yeah.
more than one.
Yes, ma'am.
You lost it.
That's great how you put her out there.
I told you to ask for the paper.
See how I helped you?
I was like, this is my first time I see it. I told you, I can't my work. I be doing my work. I was like, I'm doing my work.
This is both due tomorrow.
You said lost it.
Well, front and back. This is 2 sheets for her.
Yes, they're doing.
Be quiet.
What question do you have, Josh? You could have just asked me. You're gonna sit there and interrupt my class by trying to talk to your group for all of 3 or 4 minutes, but when I'm here to help you, you're not gonna ask a question? So, here's something I want to point out, and this is what you need to recognize. This is just some work. You would actually need a small sentence to go with this to finish this up. Why does this tell me that those 2 equations are equivalent? That's a question you still need to answer. What did we use? We ended up using the distributive. Before that, though, what was the first thing I did?
Oh, equality of division.
Equality of division? What's the proper term there? Division.
No.
Division property?
Subtraction.
Division property
Equality.
of equality. So I might make a note here. This division property of equality does what? What's the whole point of using the division property of equality?
To divide on both sides.
That's what we're doing, but what's the point? Why did we want to do this? To make the equations equal?
True.
Say again? Say it louder. To make the equations equivalent. Remember, the equations are not equal. The equations are equivalent. They look the same, but they're effectively different. This division property of equality creates equivalent equations. Notice a short sentence, but it goes back to the question about what is equivalent equations. Yes, Kelsey?
Where'd she get 3?
That's a great question. Where did you get 3 from, Dee Dee?
She just put in.
This 3?
Yeah.
What about that 3?
I divided, because there's 3, so I divide this side with 3, this side with 3.
Okay.
I
So,
mean, it's a common factor of 6, 9, and 12.
it is a common factor of 6, 9, 12. More importantly, look at where you're starting and look at what you're trying to end with.
Oh.
What can you do with 6 to get 3? Or to get 2? Divide by 3. What could you do 9 to get 3? Divide by 3. What could you do to go from 12 to 4? Divide by 3. Okay? Now, really quickly, I do want to point this out. That's not the only way to approach that problem.
Oh, I ain't got none of that.
Notice I started with this equation, and I'm trying to get this one. Because what's 3 times 2x? 6x?
6x.
3 times 3?
No.
Oh.
Could I have done it that way as well?
Yeah. Oh, I put it. No.
Notice all I'm saying is you can divide this one by 3 to get here, or that means I could take this one and multiply by 3, the inverse. There's lots of ways to do it.
So,
Either way, but you need that statement as well. to earn a 6. Yes, Edie.
Oh, I did that, but like, I put over 3, like 12, and then there was like a slide that I put about
So
12.
divide those. Because you need to finish it showing that they're exactly the same. Okay? You need to show that they're exactly the same. What do you mean? What is this number that you're referring to?
It's on here.
I'm pretty sure I know what you're trying to say, but I need you to articulate it a little bit better. Yes, ma'am. Thank you. Is this for me?
No, for me.
Doesn't have a name on here.
The difference work.
I guess it's for me.
Why does is A and C the same?
Nope.
It's not.
Nope.
Wait, that long
All right, really quickly. Ireland, are you trying to say you got the solution? No? Okay, really quickly. These are equivalent equations, but the whole goal of equivalent equations is they have the same solution, right? We want equivalent equations because they have the same solution. So, I want to point this out. Students in my Algebra 2 class did this. Don't write this down. Just watch what I have to do versus what we just did. Okay? So then they came over here and they did this. And then they did this. And then most of them stopped here because they knew x equals 1/2. Those have the same solution, right? So B is my answer because those equations are equivalent. What took less time? Property of equality or solving it out each time? Those properties of equality were pretty quick, right? Yes, ma'am.
So would you count what they did as wrong?
Nope.
Or was it still wrong?
So they both right.
Now, just doing this algebraic work will not earn you full credit. Because the question is not which equations have the same solution. The question is which equations are what?
Equivalent.
Equivalent. So you would have to connect what you did to the idea of equivalency. What you could do to finish this up is say, these equations have the same solution. So they are equivalent. Right? Your goal is to show which two equations are equivalent. So you need to say, I know that those are equivalent because they have the same solution. You got to connect those ideas. But please hear me very clearly on this. I would not count that wrong. But what I'm trying to get y'all to understand is equivalent equations look different, but they're the same, and they're quicker. The last one I'm going to tackle right now is 2, because that should help you do every other one. Could you solve each of these equations all the way out?
Yes.
You could, right? Would that take a minute?
Yes.
Yes. Okay, but instead, is there anything that I can do to this original equation to get 15x minus 60 is equal to 120?
Oh, I think it's not 6 minus 6.
Just look at the beginning. Is there anything that might help us?
Multiply?
Multiply by what?
Which one?
Looking at A.
Oh, multiply by 5.
Can I multiply by 5? Now, I gotta use the property of equality. And let's use the calculator. Did someone say how did they get that?
Oh, I said I knew it.
Oh. So when I look at this, right, I'm going to distribute, what is 5 times 3x? 15x. And then I need to distribute
60.
Minus.
plus 60
Minus.
minus 60.
Equals 120.
If you do 24 times 5, and I would assume those who are saying it very quickly, they just already did this work. But if you do 24 times 5 in the calculator, guess what you're going to get?
120.
Hey, are those the same equations?
Yeah, right.
So, now here's the point. We have shown that they are equivalent. What is the question asking?
Let's play.
What equations?
They have the same solution. So have I actually proven they have the same solution yet?
No.
No, but what could I say?
They're equivalent?
So I could say something like these equations are equivalent. So what? So what?
So it's true.
So they have what?
The same solution.
They have the same solution. It's not all of them.
Well, I got A and B.
So let's look at B. Okay, so I have 3x minus 12 equals 24. What could I do to this equation to get closer to what we have in B?
Divide.
Divide by what? I'm going to divide by 3x when I still have a 3x. I'm going to divide by 3 when I still have a 3x. Y'all, I am trying to go from here
Divide by 4?
to here. Where the heck? Where are you getting at 4? Where the heck are you getting at 4? Look at what you have. Look what you're trying to get to. What is no longer in this equation?
12.
The 12, right? So what do you need to do to get rid of that 12?
Subtract.
No.
Add.
No.
Add.
Multiply.
Say it louder.
Add.
Add 12. What's the inverse of subtraction? Addition. What is negative 12 plus 12?
0.
0. Actually, I want you to do this really quickly. Pick up your calculator. Do negative 12 minus 12. Do negative 12 minus 12.
That's 24.
That's negative 24. Is that 0?
No.
No. So if you subtract 12, will it get rid of the minus 12 there?
No.
No, that's where some of us made a mistake. But if I take minus 12 and I add 12 to it, what do I get? That's a 0. When I have subtraction, I need to add to create a 0. When I have addition, I need to subtract. So what do I need to do on the right-hand side?
Add
So negative 12 plus 12 is 0. And I'm left with 3x is equal to,
36.
ooh, is that B?
No.
No, that is not a B.
C.
That's C.
Then you divide by.
I don't even have to do anything else, right?
Yeah.
That is literally 3x equals 36. Done. If I wanted to solve it, I would divide by 3. But I didn't want to solve it. I just wanted to find the equivalent equation because I've already said equivalent equations have the same solution. Right?
B.
You say D, as in dog?
Yeah.
Okay, so how are we going to go from 3x minus 12 equals 24 to x minus 4 equals 8?
What?
How are you going to go from 3x minus 12 equals 24 to x minus 4 equals 8?
Oh.
3 divided by.
Divide by 3.
12 divided by 3.
12 divided by 3, that would be that 4, wouldn't it?
No.
So,
Oh, yeah.
so let's see if it works. Right, we just need to find something. Hey, what's 24 divided by 3?
That's
8.
That's 8. Hey, that's looking pretty good. Negative 12 divided by 3.
Negative 3.
Negative 4.
Oh,
And then
yeah,
3x divided by 3.
Add.
Worked out pretty well.
Uh-huh.
One thing I didn't show this because I was running out of room, but one thing I do want you to recognize is you need to remember that division has what property that's allowing me to do this right now? It's distributive, right? That repeated subtraction is what it is, but it has a distributive property. Because that's 3x divided by 3 minus 12 divided by 3 equals 24 divided by 3.
So what you counting if we just like turn around?
If what? If you write down what I write on the board, you're good. You're just not allowed to write down the same thing that someone else wrote down because that's copying someone else.
So you're still counting like.
If you write down what I wrote down and it is valid, yes.
Okay.
Why am I going to count against you for giving when I gave you the answers? How would that make sense?
Oh, I think I already wrote my stuff down.
Well, then you should probably check to make sure it's all right because I know your B was wrong.
I mean, yeah.
What be?
the B as in boy. Alright, so hopefully you can tackle 3 and 4. One little trick on 3. One little trick I want to point out on 3 is this. What's happening to the decimals?
They
They're
They're getting pushed away or moved or something like that? Is there anything you can do so that the decimal just moves? You would have learned this in elementary and or middle school. You can't just add a 0 though. I guess I should point this out because I don't know if you've actually learned this before. I think a lot of times y'all just kind of moved a decimal like that. Is that fair?
Yes.
Yeah? Do you know what you're actually doing when you move the decimal like that?
Add
There's another number.
You're multiplying by the number 10. Look, if I take 3 and I multiply by 10, what do I do? What do I get? 30, right? If I take the number 35 and I multiply by 10, what do I get?
3,500.
Say it again. 350. There's only one zero there. Okay? I want you to notice there's an understood decimal right here, and it's getting moved when you multiply by 10. Same thing here. It's getting moved. So if I multiply by 10, how many times is that decimal going to move? Once. If I multiply by 1,000, how many times is that decimal going to move? If I multiply by 1,000, it's going to move 3. That should be a hint, right? If you multiply by 10, that decimal is going to move once. If you multiply by 1,000, that decimal is going to move 3 times.
What is the number?
Okay? Yeah, we got to get started on the next task. But have we talked about this number 8 at all?
No, that was
easy.
I don't know.
It was easy. What's such an interesting conversation over here?
Oh, number 8 is my last one.
Okay, Josh, tell us again what you just said. You substituted. What'd you substitute?
I did. What you mean?
What'd you substitute? I got this equation. 3x minus 2y equals 12.
The x put a 2, y put a negative 3.
Okay. Notice when you have a coordinate pair, isn't 2 in this case x? That's my x value. And then the second coordinate is my y.
Yeah.
So that 2 can take the place of.
X, and then 3,
Yeah.
So 3 times 2 minus 2 times negative 3. Because remember, we know y in this one. Okay?
Yeah.
So then M.
Yeah.
I haven't said that yet.
Thank you.
What is 3 times 2? 6. And then when I multiply a negative times a negative, I get a positive. So plus.
6, 12, 12, 12.
So what is the question asking?
It's like automatic.
What coordinates can represent a solution to the equation?
Terrence, what are you looking for, dude?
No.
What are you looking for? I have no clue what you're pointing at. Use your words,
The
man.
homework.
The homework? Dude, you know I gave that homework out like days ago, right? Okay.
So easy.
What have you been doing the whole time we've been going over answers for the homework? I'm like literally trying to give you answers, and you're just like, nah, Mr. Kenny, I don't care what you guys say. I'm too cool for this.
No, it ain't that. I got a boy, that's it. You feel me? Those, though.
Yes, Kyson.
We said he was just what he-
No, that was on one of the previous ones.
You.
So look, what's the question asking?
It's
What
like all
pairs
coordinate
represent the
pairs that
solution?
represent.
So what's the key word that we want to recognize up there?
Represent. Solution.
Thank you. The detail that we've been talking about is a solution. I'm almost done with showing that this is a solution, but what is the last step? Like, what is the connection between this statement and the idea of a solution.
6 plus 6 is 20.
Why do you think that 2 negative 3 is a solution?
Cause it's on the line, it's a point on the line.
Okay, so if you know about that, that is an argument you can use. Is that it's on the line?
Yes.
But what did that point do to the equation?
Made it true.
Say it louder, Jalen.
Made it true.
Made it true. Because if you see the word solution, what are you automatically thinking about? No, because we've been over this and over this and over this. The solution is not just the answer. The solution
Is what makes the equation.
is what makes the value that makes the equation or makes an inequality true, right? Does it make it true?
Yes.
So I would make a note, the solution or the solutions make the equation true. Can I stop here though?
No.
Why can I not stop, Dee Dee?
I don't even know.
Okay, Josh? It says all coordinate points. Could there be more than one?
Yes.
Yes. You need to find all of them.
I can find the rest of the
Whatever you do, you need to explain why it's a solution. There's a couple ways you can approach it, but notice right here, I went back to the idea of a solution, and I've shown that that solution makes the equation true. Those of y'all who have already had Algebra 1, you might know some other ways to know that it's a solution, but you've got to tell me how you know it's a solution. Okay?
I can.
That's not homework. We got 20 minutes left in class. We're learning stuff. Yeah, that's your homework that's due tomorrow. Okay. Huh? What? What about it? We're just not worrying about it.
My problem it was they were talking a lot, and then it's cold, and I like to go.
I know. It was terrible of me to try to give y'all answers to the homework.
I wouldn't say, and I still got it.
Yeah, I went to sleep the whole first class period. Went to sleep that, and then I just woke up.
You gotta wake up for the.
Alright, put the homework up. Time to start a new lesson. Yes, ma'am. I'll answer the question in a second if it's not about what it's passed out.
Is it about life?
It's about what?
Is it about life? Okay.
Alright. So first things first, right? We need to know a little bit better about what a solution is. This might actually help you with the homework. So this is just a math talk. Alright? What you're going to do is you don't have to work through anything at all. Just talk with your group for a few minutes about whether 0 could be a solution to each equation. So you don't have to work it out. Just look at it and talk to your group and say, man, I wonder if 0 could be a solution. Does that make sense?
Yes.
Okay, I'll come and talk to you in a second, Tyson. So just talk with your group and figure out, do you think 0 could be a solution? Make a quick note of why, yes or no.
I wondered.
Wait, to all of them?
Huh?
To all of them?
All 4 of them.
You guys know what he said.